Hi, and welcome to Section 5, Analyzing Geographic Data. In this section, we're going to look at maps in data science and what their role is. Next, we're going to take our Chicago crime dataset and see how we can plot the locations of the crimes on a map. Afterwards, we're going to add their interactivity to our map using Plotly. And finally, we're going to conclude the course and give some final remarks. Let's get started. Maps in data science. Spatial data can bring us a lot of useful insights. It's a big field of data visualization. Here's an example of John Snow's map of a London cholera outbreak that happened in the 19th century. When cases of the disease started happening, John Snow started mapping them on the city's map. Here we can see the visualization of his drawings. And from basically this map, he figured out the center or the rough center of where the outbreak was coming from, which allowed people to basically find the contaminated water pump and stop the spread of the disease. Another nice example is the iQuant New York blog, where the author picks interesting topics around the city of New York, often showing the data on a visual map. For example, the bike accidents happening in New York, helping people avoid busy streets or dangerous streets, and similar cases where maps can help us in data visualization. Now, in this section, I would like to try out the new Jupyter Lab interface to Jupyter Notebook. It looks kind of like this. It's similar to the Jupyter Notebook interface. It just adds a bit more flexibility in the sense of having multiple panes, being able to show notebooks side by side, and so on. Now, in order to run this, we're going to use the same command as before, just appending the start.sh space Jupyter space lab to the end, which will basically just tell the Docker container to run this slightly different command and give us the new interface. Now, since we will need some custom dependencies in this section, for example, matplotlib base map and Plotly, we're going to slightly change the default image because the Jupyter Notebook Docker stack doesn't contain these libraries. So in order to do this, I've created a custom Docker file that's included in the Git repository. To trigger building a new image from this Docker file, call this command, docker build, add the rm and t properties, and basically we give it a name. We can call it Jupyter/custom notebook, or you can give it some other name. And then finally add a dot at the end, specifying the current directory. Now we can use this new image to run the same command, so Jupyter Lab or Jupyter Notebook, doesn't matter, by just specifying the name of our newly built custom notebook instead of the default data science notebook. So let's get started. This is the default screen of the Jupyter Lab that I have running here. I'm not going to explain everything, but in short, we have the files pane on the left, where we have the same view of our files, so you can navigate the folders, create a copy of the notebook from the ones I've already created, and call it Chicago Crime Map. Here is the main pane where we can see some command links, such as starting new notebooks in Julia, R, Python. We can also start terminals or text editors. If you click on the name of the notebook here, it will jump to it, open it here, and we can hide this sidebar by clicking on the Files link. Most of the keyboard shortcuts and the commands are just the same as in Jupyter Notebook, so I'm sure you won't have trouble adapting. So to get started, we're going to have our usual imports, but then there's a new one to import base map, which is matplotlib's library for working with maps. Let's run this. Okay. Now, this part is just reading the same crimes data set that we've done in a couple of sections so far, so I'm just going to skip over it. We're reading the CSV files, basically assigning it to the crimes 2016 variable. And to show the sort of information we have in here and that we'll be working on, we're going to take a look at the latitude and longitude properties, or columns actually. These are the variables we're going to be working with next.